Hello again, everyone. Today we're going to look at solving multi-step equations. Multi-step equations are similar to two-step equations, which you have already learned about. The only difference is we're adding a couple of steps. So we're going to look at two different types of multi-step equations today. The first type that we're going to look at is a multi-step equation that requires grouping, or rather combining like terms before you solve the equation. For example, it would be something along the lines of 2m plus 5 plus 3m is equal to, and we'll say negative 30. So as you can see, this does look similar to a two-step equation, with the difference being the 2m and 3m, both of them being there instead of just having one coefficient and variable. Solving the multi-step equation is actually fairly simple. It's quite straightforward. The first thing that you need to do is, like I said previously, we're going to combine like terms. Now remember that when you combine like terms, you have to have two values that have the same variable and the same exponent. So if we're looking at the problem that we have here, we have our 2m and 3m, both of which have the variable m, and they both have an exponent of 1. So we can combine those two terms, and when we combine 2m and 3m, it's an addition, because we have 2m and positive 3m, so together that creates 5m. So now we're going to bring down everything that we haven't used yet, so we have 5m plus 5 equals negative 30. And now if you look at what we have left, this is now just a two-step equation, which is something that you guys have had a lot of practice solving already. So let's go through the rest of this and we'll finish up this problem. The next step, of course, would be to use the additive inverse. So we're going to subtract 5 from each side, or rather add negative 5 to each side. And when we do that, on the left-hand side, the two values right here will cancel each other out. They create a zero pair. 5m does not change. We just bring that straight down into the next step of the problem. And then we have negative 30 and negative 5. And if we combine negative 30 and negative 5, we add those together, we end up with negative 35. Our last step, just like with every two-step equation that we've solved previously, is to use the multiplicative inverse to eliminate the coefficient. Now you'll remember that the coefficient is the number that we have in front of a variable. So to eliminate a coefficient, like we said, we're going to use the multiplicative inverse. Since we're trying to eliminate the 5, that is what we're going to multiply both sides by, the multiplicative inverse of 5, which is 1/5. So I multiply both sides of the equation by 1/5, and I'm going to create two different sets of fractions just to make it a little easier for multiplication. And when I start to solve this, I'm going to find that on the left-hand side, these values will cancel each other out, so I'm left with m. And on the right-hand side, when I multiply straight across, I end up with negative 35 over 5. And lastly, we simplify negative 35 over 5, and we get an answer of negative 7. And that would be our value for the variable m. Now if we wanted to check our work, we would take negative 7, we'd put that back into our original equation, so we'd have 2 times negative 7 plus 5 plus 3 times negative 7, and we would expect that that would equal negative 30. And if you were to pause right now and actually calculate that out, you would get negative 30. So the next thing we're going to look at is we are going to solve a multi-step equation that includes the distributive property. When we solve with the distributive property, just like it sounds, one of the first things that we're going to do is use the distributive property. So the way that these kinds of problems typically would look is something along the lines of this, where you would have 3 times the quantity of 2m minus 7 equals 15. Okay. Now, if we'll recall from previous lessons, from past work that we've done, when we are given a distributive property problem, the basic idea of the distributive property is that you take whatever value you have on the outside of the parentheses and you multiply it by everything on the inside of the parentheses. So I'm going to be taking my value of 3 and I'm going to multiply it by both the 2m and also by the negative 7. So when I multiply across, the first step, like I said, was 3 times 2m. If we multiply 3 times 2m, we get a value of 6m. Remember that when you multiply two different terms, you multiply the coefficients. The next step would be to take the 3 and multiply it by negative 7. Now remember, one of the things that you can do is if this is too confusing and it looks like it's a subtraction problem, you can always change the minus 7 to a plus negative 7. And that's okay to do. It doesn't change the value of the equation. So if I multiply 3 by negative 7, I'm going to end up with negative 21. So I now have 6m minus 21 equals 15. And once again, just like in our last problem, we've worked it out to the point now where it's a two-step equation, which is something that we should have a lot of practice solving. So we're going to go through and finish this problem off. The first step would be to use, or rather, first step was distributive property. The second step would be to use the additive inverse. So I'm going to add 21 to both sides. And remember, this time it's positive because the value in the original equation was negative 21. So I'm adding a positive 21 to both sides of the equation. These values will cancel out. They create a zero pair. 15 plus 21 would give me 36. And then on the left-hand side of the equation, I just bring down my 6m, which is the last value that I have available. Our final step, just like in our last problem, is to use the multiplicative inverse. And remember, we use the multiplicative inverse to eliminate the coefficient, or the number that's connected to the variable. So right now, the number that I have, my coefficient is 6, which means my multiplicative inverse is going to be 1 over 6. Oh my goodness, just wrote a 3 for some reason. Even teachers make mistakes. 1 over 6. So I'm going to multiply both sides of my equation by 1 over 6. And when I do that, again, I create fractions just to make the multiplication a little easier to see. When I multiply by 1 over 6, these values will cancel out. They create a value of 1, which means that it's just 1m. And then on the right-hand side, I multiply straight across, and I end up with 36 over 6. As always, our last step is to simplify the fraction if possible, and in this particular case it is possible. 36 over 6 simplifies to 6. So our final answer for this problem would be that m is equal to 6. And again, if we wanted to check that, we would take our value of 6, put it back into the equation, the original equation for the value of m, and we'd have 2 times 6, which would be 12, and then 12 minus 7, or plus negative 7, which is 5, and then we'd have the 3 times the quantity of what we just solved, which we found was 5, so we'd have 3 times 5, which of course is 15. So our values were correct.